So then let's move on. -9, this is also a very new standard or a measurement technique. It's defining the surface scan method. And again, in the same way as for the electromagnetic emission, we have a H-field probe or an E-field probe. But in this case, we are not measuring the near H-field. We are generating or forcing a near H-field on top of the IC package. And this is also done by signal generator, power amplifier, and then we need a very robust probe which can really be driven by the signal. And then, depending if it's an E-field probe or an H-field probe, we can generate a very small, it's not very small, it's in a small distance a magnetic field or an electric field at the surface of the IC. And then we are moving the probe all over the surface. And at the same time, we are checking if the IC is still working properly. But the big advantage of this measurement technique is we really get, in the same way as for the electromagnetic emission, some hotspots. We can really say, if the probe is placed here at this XYZ position, there must be something inside of the chip, inside of the microchip, which is very susceptible or acting very, in a very weird way. So therefore, we need some monitoring in order to check them. A long time ago, a colleague of mine, he was my master student at AMS, was designing some probes, and we made different kinds of probes, like small loop areas. And then we came up with an idea that it could be very useful to concentrate the magnetic fields and place the magnetic, and then force the really small concentrated magnetic fields in a very special area of the IC. Because most of the probes, they are quite big, and then they are generating a magnetic field that is spreading in a big distance. And we wanted to force the magnetic flux lines at a certain point. And this was done by using a rod of ferrite, like a pencil. And then the rod of ferrite was sharpened in the same way as a pencil. So to have a ferrite, and then a very sharp tip. And then around this ferrite rod, we were winding, as you can see here, some wires to form a loop inductance. And with this, we could really force the magnetic flux lines at a certain position. And this was then one of the measurement results. So we were moving the probe around from starting here, moving around, and in the same way we were monitoring the IC, for example, whatever, the output voltage of an operational amplifier, and depending on how far this output voltage is moving away from a predefined value without any interferences, we can then get some colored pictures. And then if the probe is located here, we can see here is the weak spot. So here is something within the IC which is very susceptible or reacting to this RF interference. And this is something that really helps the designers to figure out what's the problem inside of the IC.